In this video, we're going to go through the answers in 2.4 practice B. So in the first three questions here, it says match the inequality with its graph. So right away, what I'm thinking is, are there any hints? Just looking at the inequality symbols, none of them have an equal to, so unfortunately, I can't use a boundary point being filled in as a way to rule out one of these graphs. So what I'm going to have to do in all of these is actually solve the inequality and then match it with its graph. So number one, I've got 5 times 4 minus y is less than 25. So the first thing I'm noticing here is that I need to get y by itself, so I'm going to divide off that 5. You could distribute in the 5, but then you'll have an extra step. So I'm going to divide off the 5 as my first step. I'm not dividing by a negative, I'm just dividing by a positive, so I don't need to flip my inequality symbol. So I have 4 minus y is less than 5. I need to get y by itself, so I'm going to subtract off the positive 4. That will make this 4 and that 4 cancel out, but I still have a negative y, so it's negative y is less than 5 minus 4 is 1. And I still need to solve for y, so I need to divide both sides by negative 1. So in this step, when I divide by a negative, and also if you were to multiply by negative, that is where you need to flip the inequality symbol. All right, so now we get these negatives to cancel. Y is by itself. Y is greater than negative 1. So the graph that matches y being greater than negative 1 is B. So number 1 is B. And since I solved this, I might as well continue on writing my answers in set builder notation. There we go. Number 1 is B. All right, number 2. I'll switch up my colors here. All right, for the second problem here, I've got negative 9k plus 5 is greater than 14. All right, so I need to get the variable by itself, so I'm going to get the term with the variable in it by itself first. So I need to subtract 5 from both sides. That will cancel out my 5's on the left-hand side. I get negative 9k is greater than 9. Divide both sides by a negative 9, and again, we're dividing by a negative, so we need to flip the inequality symbol in that step. So these negative 9's are going to cancel out. We get k is less than negative 1. So what is less than negative 1? Which one of these graphs represents the numbers less than negative 1? And that is C, because all these values over here are less than negative 1. So the set of k such that k is less than negative 1 is represented by C. All right, moving on to the last one. Obviously, it has to be, number 3 has to be A. But let me just show you the work for this one real quick. So number 3, it is 2 times the quantity x minus 7 is less than negative 8. All right, so on this one, I'm going to just follow the steps just like on number 1. I'm going to divide off the 2. 2's will cancel. X minus 7 is left over. It's less than negative 4. And then add 7 to both sides. So this one's a little bit easier than number 1 because we're not left with a negative variable. We're left with a positive x when these 7's cancel. So we get x is less than negative 4 plus 7 is 3. So the set of x such that x is less than 3. Again, that one does match up with letter A. All right, so there's the first 3. Moving on. In the next set of questions here, it does say solve the inequality and graph the solution. So let me just create some number lines for graphing real quick here. And we're good to go. So on these questions here, to solve the inequality, we'll do like we did on numbers 1 through 3. So the first thing on this one is add 4 to both sides. That's going to cancel out those 4's. I get 6 plus 4 is 10 is less than negative 5t. And then divide both sides by negative 5. And of course, dividing by a negative, we need to flip the inequality symbol. So this one becomes negative 2 is greater than t. When we write that in set builder notation, we're going to say the set of t such that t is less than negative 2. So everything gets flipped around. The symbol's opening away from the t, so it needs to open away from the t here. All right, so I'm going to put -2 in the middle. My number line should get closer to 0 as I go to the right if I'm dealing with negatives, so I'll put -1, and farther from 0 going to the left, so I'll put -3. All right, so on this one, I have I have a less than symbol. It is not equal to, so I need to put an open boundary point, because if I plugged in -2 is not less than itself, so I don't want to shade that in to say that it's a solution, because it's not. And then I need the numbers that are less than -2. So I could plug in a -3. -3 is less than -2, so I'd want to shade that to indicate that it's one of my solutions. If I plugged in a -1, -1 is not less than -2, so that would indicate that it's not a solution on the right side. So either way, it tells me I need to shade to the left. All right, on the next one, number 5. This one, I have to subtract out the 2. That'll cancel it on the left. I get m divided by 4 is less than 3 minus 2 is 1. Multiply both sides by 4 to undo the dividing. And I'm multiplying by a positive. I'm multiplying by a positive 4, so I don't need to switch my inequality symbol. The 4's cancel. I get m is less than 4, so I'm going to write that in set builder notation. The set of m such that m is less than 4. So I'm going to put 4 in the middle. There's my boundary point. 3, 4, 5 on my number line. There's no equal to again, so I put an open boundary point at 4, and I need the numbers less than 4. In other words, if I plug in 3, I get a true statement, so I know I have to shade the side with 3. If I plugged in 5, it would not be a true statement. And there is my graph. Okay, on the next two, they're pretty similar. On number 6, subtract 5 from both sides. Those 5's will cancel. We end up with k divided by -2 is greater than or equal to 2 minus 5 is -3. The next step is to multiply by a -2. Since I'm multiplying by a negative, I need to flip my inequality symbol in that step. The -2's will cancel. K is by itself, and I get k is less than or equal to +6, because negative times a negative is a positive, so -3 times -2 is +6. So the set of k such that k is less than or equal to 6. On this one, it is less than or equal to. So if I were to plug in 6 into that inequality, 6 is less than or equal to 6. So I do need to put a filled in boundary point to indicate that 6 is a solution. And the numbers that are less than 6, like if I plug in a 5, that's a true statement. So anything to the left of 6 is less than 6 on this number line. So that is the way that I need to shade. Shade your solutions. All right, on the next one, subtract off the 7. We get d divided by -6 is less than 11 minus 7 is 4. And just like the previous problem, we have to multiply by a -6 on this one. Because we're multiplying by a negative, we need to flip that inequality symbol, and then we end up having these cancel. D is by itself, and we get d is greater than, negative times a positive is a negative, 6 times 4 is 24, so we get d is greater than -24. In set builder notation, that's the set of d such that d is greater than -24. So on my number line, I put a -24, get closer to 0 to the right, so there's -23. Farther from 0 on the left, so -25. There's no equal to on this one, so we need an open boundary point. And we want the numbers that are greater than -24, so that is to the right. All right, 2 more just like that. So on this first problem, I'm going to right away divide off that -2. You could distribute it in, but again, it's going to take an extra step to solve. If I divide or multiply by a negative, in that step, I need to switch my inequality symbol around. So I end up with these canceling out, the inequality symbol flips. 4 divided by -2 is -2. I have now greater than, y plus 3 is left over. The last step is subtract off the 3. Y is now by itself. -2 minus 3 is -5. So flipping this around, I get the set of y such that y is, it's opening away from y, so it should open away from y down here. So y is less than -5. Building my number line. All right, so there's no equal to, so I need an open boundary point at -5. And the numbers that are less than -5 are to the left of -5. And the last one, divide off the 6. We get 24 divided by 6 is 4. Is greater than or equal to w minus 2. And the last step here is to add 2 to both sides. So we get 6 is greater than or equal to w, which ultimately means the set of w such that w is less than or equal to 6. Again, that symbol is opening away from w here. It should open away from w there. So we have 4, 5, 6 on the number line. Oh, I'm sorry, I should put 6 in the middle. I'm going to go 5, 6, 7. There is an equal to, so I shade in my boundary because 6 is a solution because of that equal to. And then the numbers that are less than 6 are to the left of 6, so I'm going to shade to the left. And there we go. All right, on the next section, let's see, we have 6 of these and then the word problem at the end. So on this next section, it says solve the inequality. So let's go ahead and solve these. Ultimately, we want to get the variables to one side and the numbers to the other. So I'm going to start by subtracting 7n from both sides of the inequality. That'll cancel out the 7n on the right. And on the left, I have to combine like terms. So -4 is not a like term with the other 2 terms because these have n's. The coefficient, the number before the variable, tells you how many n's you have. So if I combine these, I get -12n. I still have a -4. And it's greater than 20. All right, I need the variables by itself, or in this case, the variable by itself, so I have to add 4 to the other side. So I get -12n is greater than 24. And the last step here is divide off that -12. But of course, if you're dividing or multiplying by a negative, we flip the inequality symbol in that step. So we get n is less than -2. In set builder notation, the set of n such that n is less than -2. And this one does not say that you have to graph the solution, you just have to solve. So once we find our solution, we are done. All right, on this one, I see that I have a couple of like terms right here, so I'm going to combine those as my first step. Again, there's multiple ways to do this, but I just saw those like terms, I felt like combining them right away. And then to get that to the other side, I would have to subtract 4k on both sides. So on this one, the 4k eliminates on both of the sides here, so we end up with -6 is less than -1. Is that a true statement? Well, -6 is farther from 0 than -1, so that means that -6 is less than -1. So again, in a negative world, the farther you are from 0, the less the number is. So -6 is farther from 0 than -1, so it is less than -1. This is a true statement, so there are infinitely many solutions. Infinitely many solutions. In other words, no matter what you plug in for k, it will always cancel out on both sides and you'll always get a true statement. So no matter what you plug in is true. So infinitely many solutions. All right, similar setup here as number 10. We are trying to get the variables to one side, but we have some like terms here. So let's combine those. We get 7h. So actually this one is very similar to number 11. So let's combine these like terms first, and then subtract 7h on both sides. So 7h cancels out on both sides, and we get 6 is greater than or equal to 11. So the only reason that this one's a little bit different than number 11 is 6 is not greater than or equal to 11, so this is a false statement. So there's not infinitely many solutions. No matter what you plug in for h, you'll always cancel and you'll get a false statement. So there are no solutions. No solutions. All right, and then number 13 on this one, I'm going to distribute on both sides here. Distributing my values in my parentheses, I get 6t minus 6 is less than or equal to 6t minus 10. Subtracting the 6t from both sides, they cancel out on both sides and we get -6. Don't forget that negative. The subtraction means that this is a -6 because you could write it as plus a -6. So -6 is less than or equal to -10. Is that true? Well, -6 is closer to 0 than -10. So -6 is actually greater than -10. This is a false statement, so again we have no solutions. So I'm just going to copy this one right over here. There we go. All right, moving on to the last two in this little section here. This one is similar to the last one. I'm going to distribute both of these values into the parentheses. And I get 12x minus 24 is greater than 12x minus 24. Well, I could actually stop at this point. I have one expression is greater than itself. Something is never greater than itself. It should be equal to itself. So this is a false statement. If you don't understand that at this point, you could keep going. You could subtract 12x from both sides of the inequality, cancel them out here and there, and get negative 24 is greater than itself. So at some point you should realize you're trying to say something is greater than itself, which is not true. It can never be true, so this is no solution. No solution. All right, there we go. And number 15, one more time, distribute those values into the parentheses. And we end up with 1/3 of 6, or 6 times 1 divided by 3 is 2. So we have 2d plus 6 times 4 is 24. It's greater than 2d plus 2 times 12 is 24. So one more time here, we have the same thing as greater than itself, which cannot be true. So therefore, again, we end up with no solutions. All right, going on to the last problem, the word problem here. It says you must maintain a minimum balance of $50 in your checking account. You currently have a balance of $280. Write and solve an inequality that represents how many $20 bills you can withdraw from the account without going below the minimum balance. So on this one, we are starting with $280. We're starting with $280. And we're withdrawing money. We're going to take away money from this. So we're going to lose, I'm going to subtract, and it says we're going to withdraw $20 bills. So I'm going to lose $20 over and over again. Well, if this $20 happens every transaction, I'm going to say minus 20x, where x is the number of I'll just say number of transactions. I suppose you could say the number of withdrawals. All right, so here we go. 280 minus 20x. So that's the total amount that's going to be in your account after so many withdrawals, after x withdrawals. And it says you must maintain a minimum balance of $50. So the total amount has to be greater than or equal to $50. So this part says write and solve an inequality. So there's the write the inequality, and then I have to solve this inequality. So to do that, I'm going to subtract 280 from both sides of the inequality. I get negative 20x is greater than or equal to negative 230. 50 minus 280 is negative 230. Divide both sides by negative 20. Because I'm dividing an inequality by negative, I need to flip my inequality symbol. And those are going to cancel. I get x is less than or equal to 230 divided by 20 because the negatives cancel. 230 divided by 20. 230 divided by 20 is 11.5. 11.5. So write and solve an inequality that represents how many $20 bills you can withdraw from the account without going below the minimum balance. Well, here, it's x is the number of transactions or withdrawals. I should really change that to withdrawals. I'm going to say instead of transactions, the number of withdrawals. And I'll say the number of $20 withdrawals. Okay, so you cannot withdraw an entire $20 bill a half a time. You could say that you're taking out a $10 bill, but this says $20 bills. We have to take out just $20 bills. So it's like if you go to an ATM, they don't allow you to take out a $10 bill. You can only take out the 20s. So here, we can't take out the half of a bill. Since x, the number of withdrawals, has to be less than or equal to 11.5, we could take out 11 $20 bills. We can't take out that extra 1/2, but we could take out 11 $20 bills. So that would be how we would interpret our answer here. All right, so part B says your bank charges an ATM fee, so now we're charged a little bit extra, which is charged each time you withdraw $20. So the total amount right here is not going to be $20 that you're taking out from your total balance of $280. You're now going to be taking out an additional $250, so you're going to take out $22.50. All right, so write and solve an inequality representing how many $20 bills you can withdraw from the account now without going below that minimum. So on this one, it's very similar. You still have that $280 to start, but now we're not taking out $20 because we have an additional $250. We're taking out $22.50. I'll put 0.50 so you can see that this is really money. And it's still X withdrawals, and we still have to stay above our minimum balance, it says, without going below the minimum. All right, so there's the writing part, and then I still have to solve. So just like the last one, subtract off 280 from both sides. That cancels. I get negative 2250. Negative 22.50. X is greater than or equal to negative 230. Dividing by that negative 2250 on both sides of the inequality. And just like the last one, I need to flip my sign because I'm dividing by a negative. And what I end up with is these canceling out, the negatives canceling out. So I get X is less than or equal to 230 divided by 2250 is about 10.22. So 10.22. And that's okay to round it on this one because, again, this is the number of withdrawals we can take out. So we can withdraw 10 $20 bills because we're charged that additional $250 each time. If we're not charged that $250 each time, then we can withdraw the 11 $20 bills, and we'd still have a little bit extra left over. So 10 withdrawals with a little bit left over, or 11 withdrawals with a little bit left over, based on if you have that $250 charge or not. All right, that's it. If you have questions, let me know.